Yeah, I started recording and I didn't even realize it. Okay. Welcome back to the second part of Heart Academy number 12. I think in the first half of the video I mentioned it was number 11, but I looked and it's actually number 12. So this is the next part that is on your packet for Tuesday's night's homework. And this is 8th grade only. 7th graders, I have not done a Heart Academy video to help you, but I think you'll be fine with it. Anyway, so 8th graders have an exam coming up. So here we go. We're going to fill in the blanks with these. Rational numbers can be written as a fraction, okay? Rational numbers can be written as fraction. Let me show you something as well. So that'll help out a little bit. I have a nice, neat chart that looks like this. Check this out. Rational numbers, see these? These are all fractions in here, okay? So rational numbers are fractions and also decimals. And decimals that either repeat or have a pattern, okay? So decimals that repeat or have a pattern are rational numbers as well. Fractions, decimals, repeating fraction decimals are rational numbers. Integers, just think number line. Can I find it on a number line? It's going to be an integer. Whole numbers, you know what those are, okay? Natural numbers are actually whole numbers, or natural numbers are actually whole numbers without the zero. That's it. So notice there's no zero right here. And then irrational numbers are things that are going to, decimals that would go on forever, like pi, okay? There is no perfect square for these numbers, so they're irrational because not only are they going to repeat forever, but they do not have a pattern. Pi, the decimal for pi, does not have a pattern. So it's a continuous number that's going to go on and on and on and on, and like an irrational person. So in class I always say, think of my irrational Uncle Joe, because the man's crazy, okay? And he goes on and on and on and on talking mess. So let's go back up to our notes for this one. So to help you fill this out. So rational numbers can be written as, rewind a little bit, take a look at that graphic I just showed you. Your answer here will be fractions. I'm going to abbreviate it just to save time, and you know how hard it is to write with this mouse. Okay, so irrational numbers are decimals that are, remember irrational, crazy Uncle Joe, right? So irrational numbers are numbers that are non-repeating, okay? And now I'm just going to highlight and circle instead of trying to write it. They're non-repeating, okay? And they also are non-terminating, which means they go on and on and on and on and on forever. I'll put that one right here, okay? So the next one, blank are rational numbers. Perfect squares are rational. Think a rational person is just about perfect, okay? So you can fill these into your packet, and this will help you with your homework. I'm not posting your homework tonight, because that is a review for you to make sure you understand each concept that's going to be presented on your midterm exam. Okay, so that means our last part, rational numbers can be terminating. Rational numbers will eventually end. Okay, and rational numbers can also be decimals that will repeat into a pattern. Okay, so rational numbers can be terminating or repeating decimals. So that's what we have here. Make sure you got that down. Pause for a second if you need to. Make sure it's all written down, because I'm going to erase to show you where these will go into our Venn diagram. Erased. So if you need to look at it again, remember you can always pause and you can rewind it a little bit. I'm going to move this one up and bring this one in. So with this chart, we are going to take the numbers that we have in this row and place them where they should be. Okay? So here we go. And again, if you take a look at here, look at what you got. I'm going to bring that graphic up for you again. Real number system. This one, we included natural numbers, which, and some worksheets don't include natural numbers. So natural numbers, okay, whole numbers, integers, and rational numbers. Got it? And irrational numbers, because they're crazy, they need some space by themselves. Here's another good chart that has examples. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. Whole numbers is the same thing as natural, except with a zero. Integers, think a number line. Rational numbers are fractions or decimals that make sense. So this is a ending decimal, it terminates, or a repeating decimal, or rational. Irrational are going to give you decimal answers that do not make any sense, like crazy Uncle Joe. You're irrational. So going back into the graphic up here, find the right page for it. That was last night's homework. Okay, here we go. So now I have negative 4.5. The first thing that you want to do here is make that 4.5 as a decimal. So at 4.5, I can barely see it. Basically, and I'll do it right here, change that fraction into a decimal. Here's that fraction part, right? So really what I'm asking you to do is this. Change this into a decimal for me. Okay? And then plug that back in when you're done. 5, will it go into 4? No, it won't. So 0, decimal 0. 5 goes into 40. How many times? 5, 10, 15, 20, 25, 30, 35, 40. So that's 8, okay? 5 times 8 is 40. So now I'm done with that part. Plug in the whole number. So basically what I have here is negative 3.50, okay? So I'm going to put that right up here. I'm going to change this to 3.50 or negative 3.50. And that way I'll get rid of this since it's in our graphic. All right, it terminated, didn't it? So, and it's a fraction or a decimal, isn't it? So which one is it? It's going to go into rational numbers. Rational numbers are fractions or decimals that make sense. Square root of 40. Please don't freak out about square roots. I will allow you to use a calculator to help you determine square roots because I know that this is something that you have not seen before, especially since we had such a rough beginning start of the school year, okay? So if you do the square root of 40, you're going to get this as an answer. It's going to be like 6.32 4, 5, blah, 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 and it's going to keep going, okay? It is not in a pattern, all right? So guess what? Decimal, not in a pattern. Guess what it's going to be? You named it. It's going to be irrational because it doesn't make any sense, like crazy Uncle Joe. Now I have the whole number 6. Change color. My whole number 6. Guess what? 6. I just said it was a whole number, right? 6 is also on our number line. 6 is also a very rational number, okay? Now, this one, I'm going to change into a decimal. So remember, and I'll work over here, I'm asking you to do this. 9 goes in 7, 0 time. At decimal, 9 goes into 70. How many times is 9 going into 70? Oh, you're not sure? Remember our handy dandy multiplication chart. Excuse me. Handy dandy multiplication chart. Here you go. 9 goes into 70. 7 times. 9 times 7. 9 times 7 is 63. So here we go. Whoops, wrong part. Here we go with 63. So 9 times 7, 63. I subtract. I should have 7 left over, right? So I add another 0. You know it's 7. 63. Oh my goodness, I think we see a pattern. So basically, this is repeating. I'm going to put, okay, the negative sign back on. So really what I have for this one, and I'll write it up here, or right here close to it, is negative 0.777, okay? But it's repeating. So it makes sense. Even though we don't like negative numbers, they make sense. So this one is going to go in our rational number area, okay? So is this one, because it's repeating. 0.4, repeating, rational. Look at this. It doesn't have a pattern. So guess where it goes? You named it. Crazy Uncle Joe, irrational. Negative 5. Guess what? It's not a whole number, not an integer, but it is a rational number, okay? Or negative 5, duh, I said negative 5 is not an integer, is an integer, because you can find out on the number line, right? 39, change colors, whole number. On the number line, it's rational. Square root of 16. Remember, don't freak out about square roots. So I help you determine them or give you a calculator if you need one. Okay, square root of 16 is going to be 4. 4 times 4 is 16, right? So guess what? This answer is 4. then red. Right? If our answer for that one is 4, 4 is a whole number. 4 is also an integer. 4 is very rational. Okay? And then 0. People always ask me all the time, is 0 a rational number? It is. Okay? So 4 is a whole number. 4 is a integer. It's on the number line. 4 is very rational. Okay? So that's what this chart looks like here. And looking at this chart will help you with the next page. I can't believe I did all that without recording. No, I'm still recording. Okay, great. Sometimes I can't remember. All right, so looking on to the next page. Here we go. Better be still recording. And another. Okay guys, welcome back to Heart Academy number 12. I think in the last video I said it's Heart Academy number 11. That's wrong. I looked and it's actually number 12. So I hope this is very useful to you because it has taken me forever. This is the next part of your packet. Remember, the packet is not homework. The homework sheet is homework, but we did not have time to complete the packet in class, so I'm helping you complete it right now in order to help your homework. I'm not going to be posting your homework, remember, okay? So here we go with this part right here. We're going to fill this in. And this is a wonderful graphic that I have. View the browser. There it is. So the graphic that I have that helps understand these, okay? So look, natural numbers, whole numbers, or all of these, right? Integers, or all of these, and rational numbers, okay? All of these. And now irrational numbers. Irrationals are called irrational because they don't make any sense. Irrational numbers will give you decimals that go on forever without a pattern. This looks like a pattern, but it's really not. Because I have 1, 0, 0, 1, 0, 0, 0, 1. So that's not really a pattern going on here. These will give you a pattern or they will terminate. 0.63 is terminate. 12 means it's going to repeat as 12, 12, 12, 12. So it's a pattern, okay? 3 and 5 will terminate once you turn that into a decimal. Integers, think of another number line. Whole numbers are 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 everything on a number line except including the 0. Natural numbers are everything on that number line except a 0. Got that? So that helps out when we are looking at this page that's right here, which we're going to do next. Voila. Okay. So, and if this part is repeating, then go on to the next video or whatever, because I can't remember if it's repeating or not, because I forgot if it was recording or not, so I'm just going to keep rolling. So, rational numbers can be written as, if you stop and rewind the video a little bit, you'll see the word that fits best in here is fractions. So I'm going to circle that and put that right here. Irrational numbers are decimals that are, remember, irrational like crazy Uncle Joe. So irrational numbers are ones that are not terminating, going on and on and on, and irrational numbers do not repeat. They just go on and on and on without a pattern, okay? Blank are rational numbers, okay? Terminating, or excuse me, the best one for this blank would actually be perfect squares. Perfect squares, yes, are very rational numbers, okay? And then for our last part, here you go. Rational numbers can be terminating, and they can also repeat into a pattern. I'm going to stop here because the video time says 14:35. So I'm going to think that this last part repeated, and I will check on that one in a second. And if it didn't, I will do this part on the next video.